For the acceleration that I had in the horizontal direction. I redid it, I got 1.0.
Oh,
I got a different one. So,
Are there any questions?
too many, I don't even know where to start. It's okay.
I was looking at.
I'm done.
Okay.
Yeah. I'm really good at this. Oh, I'm really good at this.
The floor is open for questions.
I do have a question.
Okay.
Okay.
So on number 1, I got the same answer for both A and D, because it's concerning the speed of the object when it's rolling on the ramp and when it's not rolling on the ramp. Does that make sense?
What's the, do you have the question there?
Yes. I like your mask.
Oh. Thank you. All right, so for A, what was your question again?
I got, like for A and D, I got both the same answer.
That,
Doesn't
no,
make sense.
does not make sense.
Okay.
Because once it's in the air, it still has acceleration, so it should be the vertical component.
And not the horizontal.
The horizontal component at this point right here, so
It
your
should be
answer.
0.
No, because the thing is going off. So table, ramp, the object comes off and then goes through projectile motion. So the first part is just a one-dimensional problem.
Right.
And I give you the acceleration, you have the distance and the initial velocity. So you figure out how fast it's going here. And then at that point, I think part B, so you have that initial speed and the angle of 30 degrees. So you break that up into components, and that's the answer to D. And then there's other classic projectile motion problems. And then at the end, what is the velocity just at the end? Horizontal component should be the same as here, and the vertical one, well, it's changing by 9.8 meters per second. Every second it falls.
Okay. That makes more sense. Thank you.
Okay. Lisa, you had a question?
It was on 4C. That was the one that I was trying.
I'm gonna take another shot that I have a printed copy of this. Apparently not. Oop, oop, oop.
And I also have a quick question on the lab.
Okay, all right, so we'll get there. So you said 4C,
Yeah. The very last one.
got projected 70 meters per second, an angle of that mess right there. That angle that I give you there will make the sine and cosine come out to be 0.6 and 0.8. So horizontal vertical components, initial velocity, so that's classic. For step, how long will the take for the object to reach the wall? Because you have the horizontal displacement of 190 meters. So how much time does it take to go 190 meters? And then how far up the wall? Okay. So what's your question?
Yeah, so I was good with like the numbers that we gotta use, but I'm confused on the signs. So with the initial velocity, that 42 meters per second, would that be a positive or a negative?
It depends on how you define it.
So I was trying to think of like, down, so my acceleration was a negative number.
Okay.
So I said down is negative,
Okay.
right? So, but I'm still,
So the initial velocity, vertical velocity would be positive.
and that's what we're dealing with here, right?
Yeah, because it's being shot at an angle above the horizontal. So horizontal here, it's being shot up like that. So you'll have the components.
Oh, so, okay, so it would be positive.
Yeah, up. If you said down is negative, then up has to be positive.
Okay.
Unless you're in some weird geometric reality.
I had kind of the same issue as him. When we're solving how high it hits on the wall, are we supposed to use the 70 meters per second, or do we use the initial vertical velocity?
All right, so whenever you're plugging into the equation,
Uh-huh.
and the classic one that, you know, whether this is the one you plug into for that particular part or not. But if you're plugging into one of these equations, you're plugging in similar types. If this is vertical, then that better be vertical and that's vertical.
Okay,
If this is horizontal, that's horizontal and that's horizontal.
okay. So then like when I use I think I had the same question, so when I use like the negative 42 meters per second, like my, for the initial velocity, then my displacement comes out as negative.
If you're making the initial vertical velocity negative,
Uh-huh.
that means you're saying down is positive. So therefore, your acceleration will be a positive number.
Okay,
But I would expect, if down is positive, then if it hits the wall above the ground, I would expect a negative displacement.
okay, I had to mix up, so my initial, okay, should be positive, that's,
If you made initial velocity negative and acceleration negative, you didn't have the thing shooting like this, you had the thing shooting like that.
okay. Gotcha.
And thus, the anti-gravity device was born. Ken?
To calculate the velocity, we have to, on the 30 degrees one, we have to recalculate with 30 degrees, or we have to do it 60 degrees.
The slope, it makes a 30 degrees with the angle, so this is 30 degrees here, and so when it's launched off there, this is 30 degrees here. So whatever your speed was, your horizontal component would be v times the cosine of 30 degrees, and the vertical downwards, whether it's positive or negative is up to you. Whatever the speed was times the sine of 30 degrees. Now, since the cosine of 30 degrees is the same as sine of 60 degrees, you could have one like this. That's a 60-degree angle. So you could have, for the vertical, done, that's v times the cosine of 60 degrees, and v times the sine of 60 degrees. So you could
That's
use
the
60
same.
degrees, but just make sure you got the right trig function. I cut you off there at the end, I apologize. Did there something you needed to ask?
No, that's all.
Okay. Other questions?
Can I ask another question about number one?
Sure.
Do you think it's at all possible that I could have arrived at the right answer for one if I split the first part like it were a two-dimensional problem? I ended
Yes,
up,
you can.
really?
Yeah, that was the longer way of doing it, but yes, you can do it.
Okay. Alright.
Especially when we get into the forces, the object on ramp is something that we deal with a lot. And, I mean, one of the reasons I don't call it X and Y, but try to use I hat, J hat, is that hopefully it's easier to tilt your axes and make that a positive direction.
Right.
Other questions? All right. I will pick up sort of where we left off with forces.